Bienvenidos estudiantes a la clase de la operaciones con científico notational. Oops, sorry about that. I had my translator button on. Let me start over here. All right, welcome students to today's lesson on operations with scientific notation. This is lesson 10. Now, in yesterday's lesson and last week's lessons, you worked with scientific notation, and with the help of the calculator, you're able to convert standard notation to scientific notation, hopefully without a problem. And now, especially after yesterday's lesson, you become a little bit more comfortable with using the calculator to do this. The main challenge of these lessons is not really going back and forth with scientific notation or using the calculator scientific notation. The main challenge of these lessons is to figure out what you're supposed to do, what operation you're supposed to do. You're supposed to multiply, you're supposed to divide, you're supposed to add, or subtract. Sometimes that's difficult to tell. So today's lesson is going to focus a little bit on the how. What operation are we going to use to solve this problem? And you can see here I've got this big picture of a Snickers bar down here. And the reason why I have this big picture of a Snickers bar is because it's only my favorite candy. Wink, wink, nudge, nudge, a little hint there. But also, when I look at word problems, I try to simplify it down to a Snickers bar. You'll see what I mean as you go through a couple problems. Now, the Snickers bar doesn't always apply to every problem, but sometimes it does help in dealing with certain problems. Okay? So let's take a look at our first example. Hopefully, your teacher has passed out the example page that you can staple or put in your notes or put in your notebook at the end of class. So let's take a look at the first example. Okay, so it says here the world population is about 7 billion. There are 4.6 times 10 to the 7 ants for every human on the planet. About how many ants are there in the world? Well, again, using the numbers and entering into the calculator is no big deal, but trying to figure out what operation am I going to use? Am I going to use addition, subtraction, multiplication, or division? Well, here let's take a look at the Snickers example. So this problem would be like saying I've got 4 kids in my class, and I have 10 Snickers bars for every kid. Well, that's going to be 10, 10, 10, 10. How many Snickers bars are there in all? Well, how do I figure that out? Well, I can just do 10 times 4, which is 40 Snickers bars. Okay, so it's kind of similar here. There's about 7 billion people, and for every person, there's 4.6 times 10 to the 7 ants. So what I'm going to do in this case is I'm going to multiply. So the first thing I need to do is, of course, convert 7 billion to scientific notation. So 7 billion, I'm going to write out 3, 1, 2, 3. So bam, bam, bam. And that is, again, you can use your calculator to do that. That is going to be 7 times 10 to the 9th. So now I've got to multiply that by the amount of ants for every human on the planet. So I'm going to do multiplication times 4.6 times 10 to the 7th ants. And again, take your time, enter this in the calculator. Go ahead and hit pause while you do that, or you can just continue listening and listening to the answer. So when you enter that into the calculator, you get 3.22 times 10 to the 17th ants in the world. Now that is a lot of ants, okay? Tremendous amount of ants, more than a handful. Okay, so again, a key word here is how can I figure out what operation? So there's 7 billion. For every person, there's 4.6 times 10 to the 7th ants. I'm going to multiply to figure out how many total ants are in the world. Okay, so let's take a look at the next example. Okay, a certain social media company processes about 990 billion likes per year. The company has approximately 8.9 times 10 to the 8 users of the social media. About how many likes is each user responsible for per year? Write your answer in scientific notation and standard notation. Okay, here we have a Snickers bar, and let's say 100 people like this Snickers bar, or there are 100 likes on this Snickers bar, and there are 20 users. Okay, and I want to figure out, well, how many likes per user? Well, in this case, I would just divide up my 100 by my 20. 100 divided by 20 would tell me that there's 5 likes per user. So the same thing I'm going to do here. I have 990 billion likes. So again, I'm going to write that out. 990 billion likes. And that in scientific notation is 9.9 times 10 to the 11th. And the company has approximately 8.9 times 10 to the 8 users. So we want to figure out how many likes per user. Keyword being per. The word per is a general clue that you're going to be using division. So I'm going to divide that by the amount of users, which is 8.9 times 10 to the 8th. So you do that division. Again, use your calculator. Use parentheses around your scientific notation numbers. And the answer is 1.1 times 10 to the third power, which in standard notation, just hit that double arrow button in the bottom right hand corner of your screen, should put it to standard notation. If not, go ahead, raise your hand, is 1,100 likes per year. Okay, again, the focus on the keyword here is per. That's going to help tell us that we're probably going to use division in this case. Okay, take a look at the examples in your packet now. Examples 1, 2, and 3. So, example number 1, the speed of light is 300 million meters per second. The sun is approximately 1.5 times 10 to the 11th meters from Earth. How many seconds does it take for the sunlight to reach Earth? Now, this one's not as obvious as to what operation to use. First thing I can tell you, this is a tremendous formula to memorize. Distance equals rate times time. Now, we want to know how many seconds, and seconds is a form of time, so we're trying to solve for time. So what am I going to do with my r to get rid of it in front of the t? Well, I'm going to divide it. So really, the formula I want to use is time equals distance divided by my rate. So that's going to tell me how many seconds it takes for the sunlight to reach Earth. So go ahead and do that problem. Go ahead and try exercise 1, 2, and 3, and then, exercise 1 and 2. And then we'll come back. So go ahead and hit pause. So the first thing I did in exercise 1 is I converted 300 million to scientific notation, which is 3.0 times 10 to the 8th. And I used my formula, distance divided by rate, to figure out my time. So I put my distance in, which is 1.5 times 10 to the 11th, divide by my rate. Gives me 5.0 times 10 to the second. Now, that is actually 500 seconds, and the cool thing about that is that means that it takes about 7-8 minutes for the sunlight to reach Earth, which means every time you're looking up at the sun, you're actually looking into the past. Think about that one for a moment. Okay, so take a look at exercise 2. Now, again, exercise 2, we have the mass of the moon, which is 7.3 times 10 to the 22nd, and it takes approximately 26,000 moons to equal the mass of the sun. So determine the mass of the sun. So how do I know what operation to use? Well, in this case, I would use my Snickers formula again. So I would say each Snickers weighs 5 pounds. And if Johnny takes 20 Snickers bars, how much would he weigh in all? Well, 20 times 5 is 100 pounds. Because each Snickers weighs 5 pounds, and I need 20 Snickers bar, I would take 5 times 20. And you can see I'm being interrupted here. So on by Izzy and Eliana. So we'll continue on in a moment. Okay, so that's another example of how we can use a Snicker bar to show that we are going to use multiplication. Because each moon weighs this much, and if the sun weighs this many moons, I'm going to multiply the amount of each moon by 26 million to get this big giant number, and that is the weight of the sun, or the mass of the sun. Okay, take a look at example 3 in your on your little note sheet there. Okay, it reads, in 2010, Americans generated 2.5 times 10 to the 8 tons of garbage. There are about 2,000 landfills in the United States. Assuming that each landfill is the same size and that the trash is divided equally among them, determine how many tons of garbage would be sent to each landfill. So again, big clue here is the word divided, and basically we're taking all of this garbage, dividing it up into this many landfills. So let's just quickly go ahead and write 2,000 as a in scientific notation. So that's 2.0 times 10 to the third. So I'm going to divide the amount of garbage we have. So it's the amount of garbage by my landfill. So that's going to be 2.5 times 10 to the 8th divided by 2.0 times 10 to the 3rd. Please use your calculators. When you use your calculators, you get 1.25 times 10 to the 5th tons of garbage in each landfill. Okay, so again, I divided in this one. Okay, take a look at the next problems. Example 4 and example 5. Go ahead and try exercise 4 and exercise 5 on your own. Hit pause, we'll come back, we'll go over them, but definitely give it a shot on your own here. Okay. Okay, so in exercise 3, the mass of Earth is 5.9 times 10 to the 24th kilograms. The mass of Pluto is that large number. Compared to Pluto, how much greater? Now there's the key word. How much greater is Earth's mass than Pluto's mass? So there we're comparing two things. We want to know how much bigger something is, so we're going to subtract the smaller item from the largest item. So this big number, you could enter in the calculator. I just simply started at 0 and counted my way 1, 2, 3, 4, 5, 6, 7, all the way up to 22 instead of entering that number in the calculator, but you can do it how you want. So anyways, you subtract these two guys in your calculator. Please use parentheses. Let me put those in. Bing bong, bing bong. When you do that, you get 5.877 times 10 to the 24th. Okay, in exercise 4, you're going to use the information in your previous problems to find the combined mass of the Moon, Earth, and Pluto. So combined mass, that's going to be addition. I'm adding them all up. I'm adding my Moon plus my Earth plus Pluto. So you can see I have that down here. So I'm adding that up. Okay, sorry about that whining in the background. That was my dog. He had to go out. I put him out. We're good to go. Let's focus on Earth, Pluto, and Moon right now. So again, we got Earth, Pluto, and Moon. Add up all three of those items. We get 5.986 times 10 to the 24th power. Okay, and then the last one. How many combined Moon, Earth, and Pluto masses are needed to equal the mass of the Sun? So in this problem, it's not exactly obvious that we're going to be using division. So let me go back to my Snickers problem. Let's say I have a giant Snickers bar that represents the Sun. And then I have this smaller item that represents, who knows, maybe Three Musketeers, Milky Way, and take 5. Okay, it weighs this much. And I want to know how many of these guys does it take to equal the mass of this guy. Well, what I'm going to do is I'm going to see how many they have in there. I'm going to divide it. And by dividing the giant Snickers bar by these guys, it will tell me how many of these guys will fit in there. Hopefully that helps. I don't know. But anyway, so we're going to take the Sun, which we got from one of the previous problems, 1.898 times 10 to the 30th. And we're going to divide it by the total, which we got in our previous problem, Earth, Pluto, and the Moon, and divide it by that amount. That part represents the bunch of candy bars, the smaller mass. So to figure out how many of these guys fit into the Sun, we have to divide, and 3.2 times 10 to the 5th is your answer. Okay? So I hope this helps. Again, try to think of the problems in terms of Snickers bars. If that doesn't help, well, at least now you know that Mr. Tay likes Snickers bars. So you get that going for you. Okay? At this time, your teacher should be giving you an exit slip to work on. And when we're done with the exit slip, you can work on your homework. And again, as always, if you have any questions, please see your teacher ASAP. All right, guys, good luck, have fun, and that's all I got.